Lesson 1-7 is about more properties of integer exponents. We've got a couple more properties we're going to add today. We're going to start here by just looking at some patterns. We've been talking about integer exponents, and when we simplify those down to just a number by itself, the way we'd usually see those, that's called standard form. So 3 to the 4th power is 81. 3 to the 3rd power is 27. 3 to the 2nd power is 9. 3 to the 1st power is 3. Wonder what 3 to the 0 power is. We really don't know anything about this other than maybe we could extend our pattern. So let's look and see what kind of pattern we have going on in standard form. What could be happening to 81 to get down to 27? I mean, I could subtract 54, but that pattern wouldn't keep on going. So maybe to get a smaller number, instead of subtracting, maybe I'm dividing. Well, I could divide by 3. Going from 27 to 9, that's also dividing by 3. Going from 9 to 3, that's also dividing by 3. So what if I divide by 3 again to get my next answer? What's 3 divided by 3? That's just 1. So 3 to the 0 power appears to be 1. Well, that is a fact. If we take any number, any expression, and we raise them to the 0 power, it equals 1 every single time. So any number, any base raised to the 0 power is 1. So let's look at that in a problem, in an example. Example 1, we're just going to evaluate. So problem A, 3 to the 0 power, we already learned that that is 1. What if we have a decimal, negative 4.9, and it's raised to the 0 power? Well, our rule says any expression raised to the 0 power is 1, so it equals 1. We could have an algebraic expression, negative 2x squared, y to the negative 4th power, z to the 14th power, but all of that is raised to 0 power. It's all within a parenthesis and 0 is outside it, so that also equals 1. Well, we know what a 0 exponent does now. That's a very easy one to deal with. Every single time you have a 0 exponent, it equals 1. But let's think about negative exponents. You know, we're just counting these down. 4, 3, 2, 1, 0. Let's try negative 1. Maybe even look at what 3 to the negative 2 power is, or negative 2nd power. So if I want to keep my pattern going on standard form, it looks like I could divide by 3 again. So let me divide by 3. Positive 1 divided by 3. We could write as a decimal, 0.3 repeating. But the easiest way to write it is just a fraction, 1/3. That's 1 divided by 3. Well, I could try this again. I'm going to divide that by 3. 1/3 divided by 3. And at this point, you might want to break out a calculator. 1/3 divided by 3. Well, 1/3 divided by 3 is going to be 1/9. Oops. You might think about that just a minute and realize that that is 1/3 squared. So using this, we actually do have another rule when dealing with negative exponents, where we can write them like they are here in standard form with positive numbers, positive exponents. So as a rule, any expression with a negative exponent is equal to a fraction of 1 over the expression with a positive exponent. We could write it as any expression with a negative exponent is the same as writing it as that same expression, 1 over that same expression with a positive exponent. Okay, so example 2, we're going to simplify. We have 4 to the 3rd power divided by 4 to the 5th power. When we think back to yesterday, we're dividing like bases. So we could show this. Let's just go ahead and do that. Let's divide like bases and say, well, this is 4 times 4 times 4 divided by 4 times 4 times 4 times 4 times 4. And we have 4 over 4 multiplied 3 different times, and 4 over 4 is 1. So those cross out. 3 pairs of 4s cross out. And we end up with no 4's in the numerator, which we'll just use this placeholder 1, over 4 times 4, which is 4 squared. And we could write that as 1 over 16. We could write it in either form. It's equivalent anyway. We could also think back to our rule from yesterday that said when using the rule that when dividing like bases, 4 cubed divided by 4 to the 5th, they're like bases, that we could keep the base and subtract the exponents. And 3 minus 5 is negative 2. Well, that doesn't quite look the same. So I think I'm going to look back at our new rule today that we've added about negative exponents. It says that any expression with a negative exponent is equal to a fraction of 1 over that expression with a positive exponent. And for me, it's helpful to look at that little algebraic rule. And it shows that I'm going to keep this the same, except I'm going to write 1 for the numerator, keep my base 4, but change my negative exponent to a positive exponent, and I get 1 over 4 squared, and that matched what I just worked out. We have 5 to the negative 8th power. I'm just going to use my rule now. My rule says I can rewrite it as a fraction, where 1 is my numerator, and I'm going to keep my base 5 and change my negative exponent to a positive exponent because it crossed, because it was negative, so it goes below the fraction line to be positive. So that was very simple using the rule. The C part, we have 1 over 2 to the negative 4th power. This looks different. So I'm just going to start with something I know. I'm going to leave this 1 in the numerator, but I'm going to rewrite 2 to the negative 4th power where I can have a positive exponent. So this is going to become a complex fraction. It's a fraction with a fraction included. The denominator will be a fraction. 1 over 2 to the positive 4th power. Well, from here, I could rewrite this. Let me just write it out where it may, just kind of adding a couple extra steps to think back to 7th grade math when we are dividing fractions. We have 1 divided by 1 over 2/4. That's the same thing that we've just written. We just changed our fraction line to dividing because they're the same thing. Well, thinking back to dividing fractions, we're going to keep our first number, 1. Going to change divide to multiply, and then we flip our fraction. 2 to the 4th power over 1. And so this is just 1 times 2 to the 4th power. Oops. And that's 2 to the 4th power. It's the same. Now I will point this out. You can show these steps every time, and that would be correct, and you're able to do that. But you might just notice that this just seemed to flip our rule. We had 1 over a base to a negative exponent. Really, we just moved that base to the numerator and it became a positive exponent. So this is the same thing as saying 2 to the 4th power over 1. Really, our base and exponent crossed the fraction line and changed signs. And that's really all we're doing every time. So now I'm going to let you try a couple problems. I'm going to let you simplify each of these. Go back, look at your rules, especially the first few times you try these. And go ahead and pause your video and then come back in just a little bit to check your answers. Okay, so for number 1, you'll notice that negative 19 is in a parenthesis, meaning that everything in that parenthesis is together, and we're going to raise it to the 0 power. So everything is raised to the 0 power. That means it equals 1. Be careful. Had this have been written this way, negative 19 to the 0 power, then the only thing raised to the 0 power was 19, so this would have been negative 1. And that's not the problem we had, so be very careful about that parenthesis. Got to use order of operations here. Okay, so now let's look at the second problem. We had 5 to the negative 3rd power. Going back to our rule, to make this negative exponent a positive, we're going to rewrite it as 1 over, keep the base 5, and change the negative exponent to a positive. And we've simplified this.